Hello again. I apologize for the stream quality, for it being glitchy. We know that school Wi-Fi isn't the best. However, we will have a single video of me going over all of the study guide, basically editing the two live streams together into one nice video where you guys can watch through without any of the glitches. Without further ado, I want to try and finish up with 31 here. Again, for 31, we're trying to simplify this expression here to its basic form. To do that, we're using that shapes method. So for x's, I'm going to group together with these red circles. So I'm going to group together that negative x, this negative 2x. I'm going to group together this plus 2y. It's the only 2y, or that's the only y value I see. But I'm going to group together this plus 4 and then this minus 15. So I could rewrite this problem as negative x minus 2x plus 2y plus 4 minus 15. And now I just solve it out all together. This negative x minus 2x gives us negative 3x. That 2y has no other like terms for it to combine with, so it just drops down to give plus 2y. And then this plus 4 minus 15 do combine together to get negative 11. And then our finished answer here is just going to be that negative 3x plus 2y minus 11. We're good now to move on to that problem number 8. For learning goal 8, we want to write the equation for 33. We don't need to solve it, we just want to write this equation where you purchase X items for $5. Now think about when you're purchasing these items and think about for if the total cost is $50. When we say that the total cost is $50, we know that this equation, whatever it is going to equal $55. But when we think about purchasing an X item for $5, it's almost like you're purchasing a candy bar for $5. And if you purchase one candy bar for $5, you're spending $5. If you purchase 2 candy bars, you're spending $10. If you spend 10 candy bars, you're spending $50. So it's a multiplication aspect that we want to combine between this X and that $5 here. So we want to write it as 5x is equal to 55, where you purchase X items for $5 each. The total cost is $55. So moving on now to our learning goal number 9. For learning goal number 9, we want to solve the expression here. Now for solving these expressions, we want to use that inverse operation that many of you guys have down very well. For this inverse operation here, I already know you guys are angsting to just put that line down the middle, and then we want to do the opposite of that minus 19, which is you're adding that 19. Yeah. So we add that 19 plus 19 to both sides. These two 19s cancel out because negative 19 plus 19 goes to 0. So it's a cancel out, leaving you just with y equals 12 plus 19 here gives us that 31. That there is our answer here. Now to double check these answers, what I'd love for you guys to do is to plug this value that you solved back into the original problem. Now it seems pretty easy and intuitive to do it here, where we're just plugging in that y minus 19 equals 12. We're replacing that y with 31 minus 19 equals 12. Well, 31 minus 19 does give us 12. And since we got a true statement of 12 equals 12, we know that this value here that we found is correct. Let's try that one more time here with x plus 19 is equal to 12 here. We still start the same way by putting that line right down the equal sign. Then we want to do the inverse operation of plus 19, which is minus 19. Whatever we do to one side, we do to the other. And now these two 19s cancel out, leaving us just x with 12 minus 19 giving us as negative 7. So we get this answer here, and we want to double check our answer by plugging it back into the original equation. where we want to plug in that x equals -7 into that x plus 19 equals 12 equation. So -7 plus 19, we want to try and solve that out here. Well, -7 plus 19, that gives us 12. Awesome. And we know that 12 equals 12. So since we got a valid equation, we know that this here is 100% correct. We're able to move on now to that learning goal number 10. For that learning goal number 10, we'll be taking a look at these simple one-step equations here, where we want to try and solve each of these equations here by just taking a single step. Now, 39 and 41, 43 and 45 are grouped together in a way, where I want to show you guys to solve out 39, you'll do the same steps that you would want to do in 41, where if we see this x divided by 2 is equal to 16, we know our first step to solve for x is to put that line down the middle, and then we do the inverse operation affecting our variable. The inverse of divide by 2 is going to be multiply by 2. Whatever we do to one side, we do to the other. And we know that these divide by 2's and times by 2's simplify out, because 2 divided by 2 times 2 simplifies down to 1, not 0. So we're left with x on this side, where 16 times 2 gives us 32. And now we want to double check our answer by plugging this back into x divided by 2 is equal to 16. 32 divided by 2 is 16. And we know that 32 in half, if I were to split 32 in half, gives me 16 again. And since I got 16 is equal to 16, I know that value is correct. But notice the similarities between 39 and 41. In 41 here, we're given x over 2. Since we have x over 2, we know that fraction is just the division between the numerator and the denominator. So really, all we need to do to solve out for that x is to multiply by the denominator. We multiply by 2, multiply by 2. These two 2's simplify out, leaving us just x is equal to 16 times 2 is 32 yet again. We want to plug this into that equation just to double check our answers. We're plugging this equation into that x over 2 is equal to 16. Well, 32 over 2. Well, we know 32 divided by 2, like we did here, is equal to 16. So we know that this answer is 100% right. Notice the connection between this divide and this fraction. If you ever have a variable on the numerator being divided by some number in the denominator, you just multiply that bottom number to both sides to get rid of it. In the inverse way, if we were given these problems, like 43 or 45, notice how we have 2 times y is equal to 16. Our first step is still the same. We put that line down the middle, but now we want to do the inverse operation of multiply by 2. Well, the inverse of multiply is going to be divide, and we want to divide by 2 here. Whatever we do to one side, we want to do to the other. We know these 2's both simplify out, leaving us just y on this left-hand side. And we know 16 divided by 2 gives us 8. Now we want to double check this answer by plugging in this 8 into this expression here, where we get 2 times y is equal to 16. 2 times 8. We know 2 times 8 is 16, and since 16 is equal to 16, we know that that value there is 100% correct. Let's try that one final time here, but notice again that this coefficient in front of that variable y is directly next to that value of y. Since it's directly next to it, we know that they're multiplying each other. So 2y is equal to 16. That first step is still to put that line down the middle. And then we want to divide by 2. We're dividing by 2 because that inverse of multiply is divide. These two 2's simplify out, leaving us just y by itself is equal to 16 divided by 2, which is 8. We now want to double check our answer by plugging in that value into the original equation of 2y is equal to 16. or 2 times 8 is equal to 16. And we know that 2 times 8 does give us 16. Since we got a valid equation here, we know that our answer here is 100% right. We're now able to move on to that learning goal 11. Where in learning goal 11, we want to write out this sentence and then solve for it. For this sentence here, a taxi cab cost $5 plus $1.75 per mile. And it's this per part here that I want to try and hark on in a second. What is the total cost of a 4-mile taxi ride? For this equation here, what we could write is that y is going to be the total for the whole taxi ride. We have no idea what that's going to be. We know y is going to equal $5 here plus this mini little expression where it's going to be $1.75 times x. Now, x is going to be the number of miles because it's specified here that we're driving these 4 miles, and we can plug 4 in for x. Since it's a per value here, we know that per infers that it's going to be a multiplication. So this 5 plus 1.75 times x is the written equation for this problem here. We now want to plug in 4 for that value of x, where y is equal to 5 plus 1.75 times 4. Now we just multiply this out. 1.75 times 4 is going to give us, let me double check with the calculator. That's going to give us, what, 7? I believe that gives us 7. Just want to double check real quick. Yeah, it gives us 7. Plus 5 here. And we know that $7 plus $5 here is going to give us a total of $12 for the total ride that would take us 4 miles in that taxi. We now want to try and explore learning goal 11, where in learning goal 11, we want to find the area of these 2 parallelograms. Now we know for parallelograms, it's the same equation as if it was a rectangle. All we need to do is multiply the base of this figure times the height of this figure here to find the area of the inside shape. Now the base of this parallelogram is going to be this number on the perpendicular side of this height. What I mean by perpendicular is notice that this value of 10 is 90 degrees from this value of 5. We know the base here is going to be 10 centimeters times the height, which is going to be 5 centimeters, because it measures the distance from one edge of the parallelogram to the other edge of the parallelogram. So we do 10 centimeters times 5 centimeters to find the area. We just take this 5 times 10 here, and we get 50 centimeters squared, since there's 2 centimeters multiplying each other. And this here is the total area for that parallelogram. We're now able to look at 51. What is the area of this parallelogram? We're still going to use that equation where it's base times height to give us our area here. We find that our base now is this value of 9 inches. Notice that the base does not need to be the side that's flat from the paper. It's just the side length here that's exactly 90 degrees from this measurement of the height. So our base here is 9 inches. Our height here is 7 inches, making our area equal to 9 times 7, which is going to give us 63 inches squared, because we're doing inches times inches. This here is our area for this parallelogram. Now let's try out these problems here for our learning goal 13. Where in 13, we're trying to find the area for these triangles. It has a similar kind of equation for these triangles here. We're going to take the base of the triangle. We're going to multiply it by the height of the triangle. and then we're going to divide that whole thing by 2 to find the area. Now for this equation here, we want to identify that this base here is this bottom value here that is perpendicular from this value, which makes it the height. The base and the height are always at 90 degrees from each other. So we don't even need to know about that 14 centimeters being that diagonal or this 8 centimeters being that other side length. All we care about is that the base here is 9 centimeters. The height here is 6 centimeters. And we're multiplying those two values together and then dividing by 2. So we can say that 9 centimeters times 6 centimeters gives us 54 centimeters squared. And then we want to divide that by 2 to find the total area. 54 divided by 2 gives us that total area there of 27 centimeters squared. Try that one final time here with 55 here. What is the area of this triangle? Well, luckily for us, we still have that equation of b times h divided by 2 is equal to a. And we can clearly see that the base and the height are already 90 degrees from each other, where the base is going to be that 4 centimeters, and the height now is going to be 3 centimeters. So we just do 4 centimeters times 3 centimeters divided by 2. We know that 4 times 3 centimeters give us 12 centimeters squared divided by 2, where that total area of that triangle here is equal to 6 centimeters squared. Now, we're going to step away from area for a moment and then step into our learning 14 or volume. Volume now is multiplying 3 numbers or 3 dimensions to find the internal area of a physical shape. Now, I don't want to use the word area because we're using the internal volume of these figures that we want to try and find. We know that for volume is just going to be that base times height again, but then we're multiplying it by that third value of length. And this here finds the volume for these figures. We still know that the base here is going to be that 12 feet. We still know that the height here is going to be that 8 feet. And then in this case, we know the length here is going to be that 3 feet. And we can say that 8 times 12 times 3 here is going to give us, let's do our calculators. I'm going to do 12 here, my bad, times 8 times 3 gives us 288. 288. We now list the units for this here. We know we're dealing with feet, but since we multiplied feet times feet times feet 3 times, we know it's 288 feet to the third power. Now this is how we find volume. We just multiply those 3 dimensions to each other. However, in question 59, we're given the volume and we're asked to find that missing side length. For 59, what is the missing dimension of the prism if the volume is 44 feet to the third power? Messed up that in the key. What we want to try and write is that equation of b times h times L is equal to V, and then replace these variables with the 3 known values. So we know this base here is going to be equal to 11 feet. We don't know what the height is in this case, but we do know that the length here is going to be equal to 2 feet. And we know that this volume here is going to be equal to 44 feet to the third power. We now want to solve for that value of h. First things first, let's multiply this 11 times that 2. What we end up getting is 22 feet squared times h is equal to 44 feet to the third power. We now want to use that inverse operation. We're going to put a line down the middle, and we're going to divide both sides by 22 feet squared. And then we end up getting this answer where the 22 simplify out, leaving us just h is equal to 44 divided by 22 gives us 2. Feet to the third divided by feet to the second just leaves us with a single foot. So we know height here is equal to 2 feet. That covers our area for parallelograms, triangles, and volume. We're now moving on to our learning goal 15. We're in learning goal 15. We want to deal with inequalities. For these inequalities, we want to determine which value here is greater or less than. For question C1, we want to say that -6 is less than -5 as that reminder on why -6 is less than -5. We draw a number line here, and we place -10 here, and then +10 here. We know that numbers on the left-hand side of this number line are smaller than those on the right-hand side. So if I were to place that -6 right about here, and that -5 right about here, I know that all the numbers to the left-hand side of -5 are smaller than -5. So I can say that -6 is less than -5. For 63, it's a bit of a tricky question. We're still dealing with negatives here, but now we have decimals. For these decimals, if I were to zoom in between this -2 and this -0 area of our line graph, and I wrote out this line graph from 0 to -2 with -1 right in the center, I could plot that -1.5 and that -1.5 on this graph. Notice that -1.5 is in between -2 and -1, but then in between -1.5 and -1 is that -1.25. Since -1.5 is further to the left on this number line, we know that it's less than -1.5. We can write that sentence of -1.5 is less than -1.25. We're now going to explore these inequalities a little bit further. In our learning goal 17, we're going to write and solve these inequalities. What inequality is the product of 2 and x is no more than 8? So we know on the left-hand side of this inequality, we're going to write the product of 2 and x, which is just 2 and x. You know it's going to be compared to this 8 here. Now I want to try and think about what inequality represents is no more than. And I can use that example of like money in my pocket. If you were to guess the amount of money in my pocket, and I said I have no more than $10 in my pocket, you wouldn't want to guess 12 or 15 or $100. They just said there's no more than 10. 10 is the largest value that it could be. Since it's no more than 8 here, we know 8 is the largest value between 2x and 8. So we're able to say this is less than, in this case here. But since it is no more than, we know it could be equal to 8. Think about the money example in my pocket. I have no more than $10 in my pocket. And if you guessed that I had $10 in my pocket, you would be correct because it's not more than $10. To include that value of 8 here, we want to put this line underneath that inequality to say it's 2x is less than or equal to the value of 8. Let's try that one more time here for 67. In 67, what inequality is the sum of 2 and x is less than 8? Well, the sum is just going to be 2 plus x. And since there's no word than here, we know we're not going to switch it around. Is less than 8 is less than 8. These two here are the written inequalities for 65 and 67. Let's move on to that next learning goal here. We want to try and solve out these one-step inequalities. Now, for these inequalities, when it comes to addition and subtraction, we don't do anything with the inequality symbol. We treat it as if it was an equal sign, where if we are only subtracting some number or if we're adding some number to both sides, we do not flip the inequality. For question 69, we want to subtract 5 from both sides here, and we treat that inequality just like an equal sign, where it drops down. 19 minus 5 here gives us 14. These two 5s here cancel out, leaving us just x is less than or equal to 14. Let's try that one final time with 71, where we're just adding that 4 to both sides, where these 4s cancel out, leaving us just x is less than 14 again. For these problems here, if you're adding or subtracting some number, do not flip the inequality. This will change later on in these. We'll take a look here at example 19. We want to try and find the mean of this data set. To find the mean of the data set, it's just the average number. To find the average number, you take the sum of the data set and then divide by the number of values that you added together. For 73 here, we have 20, 40, 10, 10, and 70. Our first step is add all those. So we do 20 plus 40 plus 10 plus 10 plus 70. 2 plus 4 gives us 6, plus 1 is 7, plus 1 is 8, plus 7 here gives us 15. So 150 is the sum of those numbers there. We want to count to see how many numbers we added. 1, 2, 3, 4, 5 numbers in total. So we want to divide that 150 divided by 5. And we know that the mean for this problem then is going to equal 30, because that there is the sum divided by our value here. We're now able to move on to 75. For 75, we're going to add these numbers again to find the mean. 65 plus 70 plus 20 plus 45 plus 60 plus 85 plus 90. I want to kind of show you guys a couple of tricks for adding a couple of these numbers together without using a calculator. I'm going to group the numbers together and just keep them in the back of my head. I can group 65 and 45 together and get that 65 and 45 kind of connect to get 110. I'm going to keep 110 in the back of my head. I know that 70 plus 20 here gives me 90, and that 90 pairs up with that 110 really well to give me 200. Now I'm going to try and pair up this 60 with this 90 here. That 60 plus this 90 gives me 150. I know that 150 plus 200 gives me 350. And now 350 plus 85 is a much simpler task than just adding all these numbers together. And I know that 350 plus 85 here is going to give me 435. And then from 435 here, we're able to divide by the number of values we added. And these number values are 1, 2, 3, 4, 5, 6, 7. So now we want to divide this here by 7. And we use our calculators for that. And we're getting 435 divided by 7 gives us that 62.14. Let me double check my math with adding 65 plus 70 plus 20 plus 45 plus 60 plus 85 plus 90. Give us 1 second. Let me do math again. Kind of messed up my calculations. Plus 2 plus 5 plus 85 plus 90. Yeah, gives us 375. So it doesn't give us 475, it gives us 375. That was my bad math. Then we divide that by 7, and then we get that number of 53.5 as our final answer. I'm going to double check that one last time. 1, 2, 3, 4, 5, 6, 7. 65 plus 70 plus 20 plus 45 plus, there it goes. Oh, it was 40. My bad. I apologize for this mistake. 40, sorry, I'm just adding to my calculator. I keep adding it wrong. 65 plus 70 plus 20 plus 45 plus 60 plus 85 plus 90 is in fact 435. We then divide that sum by 7 here. We take 435, divide that by 7, and we end up getting that fraction of 62.14 as our final answer. This here is not right. That was my bad math. For finding the mean, it's adding the numbers together, and then you divide the number of numbers that you added. So we divided 7 in this case, because there were 7 numbers that we added. I divided 5 in this case, because there was 5 numbers added. Going on from mean, we're looking at the mean now. We're going to find the median of this data set. For the median, what we first need to do is order these numbers from least to greatest. So for this set here, we're given 10 as our smallest number here. So we can cross 10 out, and then list it as 10, comma, 10 again, comma, 20, comma, 40, finally 70 here. We want to say that the middle number here is going to be the median. So 20 is the median for that data set there. We now want to look at this data set, ordering them from least to greatest. From least to greatest here, we're going to 20. That next number is going to be 45. After that, it's going to be 60, then 65, then 70, then 85, and then 90. Then we just want to find that middlest most number, which happens to be 65, which is the median number. So we know 65 is our answer for this question 79. We're now able to move on to that final learning goal here on our data sets, where this final learning goal for our data sets were about the ranges. The ranges here, we're going to take the smallest number and then subtract the largest number and then subtract it by the smallest number. So we take this 70 here and then we subtract it by that smallest number of 10, and we're able to say that the range of that data set is equal to 60. One more time here for 83, we take that largest number of 90 and then we subtract it by that smallest number of 20 to get the range of 70. Now we're able to move on to that learning goal 22 about trying to simplify these expressions yet again, but now with negative numbers. So we're still going to use that shapes method to group these problems together. We're going to group this 4x and this minus 2x with this minus 5y and this 2y. When we're grouping these together, we want to keep those operations directly in front of the terms. So when we group these together, we end up getting this 4x minus 2x gives us 2x, minus 5y plus 2y gives us negative 3y as that final answer. We're able to try that one more time here with 87, which is kind of a funny answer. We're going to group together all of our y value first. I'm going to box in this minus y and then this plus y. I'm going to circle in this minus x and then this plus x. And I'm going to triangle in this minus z with this plus z. If I were to rewrite this in that green order, we have that negative y plus y minus, let me do that in black real quick, minus x plus x minus z plus z. And if we were to actually solve this out, minus y plus y gives us 0, minus x plus x is 0, minus z plus z gives us 0, 0 plus 0 ends up with 0 as our finished answer for 87. When you combine these negative with these positive, you get a 0 as that finished answer. We're now going to move on to that next learning goal of learning goal 23. For learning goal 23, we want to simplify these expressions here, and as a reminder, we want to use that distribution property to solve these problems out. What I mean to say when you want to distribute is you want to take this first leading number here, 3 in this case, and you want to multiply it into everything inside the parenthesis. So what we're really doing is 3 times 2 and 3 times x, 3 times 2 plus 3 times x minus 15. Notice how that minus 15 doesn't have a distributed 3 into it. So we have 3 times 2, which gives us 6, plus 3 times x, which is just 3x, minus 15. We now want to combine like terms, that 6 and that minus 15, combine together to get us negative 9, where that finished expression is 3x minus 9. Now, notice for 91, we have this 15y minus this here, where we want to take this negative 3 and want to multiply it into 3y and 2x and negative 3. So we're multiplying it into all the values inside of the parentheses. We have 15y, negative 3 times 3 here gives us negative 9y. Negative 3 times 2 here gives us negative 6x. Negative 3 times negative 3 gives us that positive 9. Now we're able to put together like terms. We only have those two like terms of 15y and that negative 9, which combine together to give us 6y minus 6x plus 9. This here is that simplified expression. None of the three terms there can combine together with each other. Now we're going to move on. For these next two problems here, for learning goal 24, we want to solve these expressions here by just using a single step. For these single steps, we already know that these coefficients directly in front of those variables there are just multiplying those variables. So for that single step there, we're able to put the line down the middle and then divide by that negative 4. Whenever we do one side, we want to do the other. And remember, whenever we divide a negative by a negative, we end up getting a positive number. So these 4's here simplify out, leaving us just x is equal to positive 3. So now let's just double check this answer by plugging this back into that negative 4x is equal to negative 12. So I have negative 4 times 3 is equal to negative 12. I know negative 4 times 3 actually does give me negative 12. And since I got negative 12 equals negative 12, I know that x does in fact equal 3. Let's try that one more time here, where we want to try and put that line down the middle, divide by that coefficient of negative 3 on both sides. We know these negative 3's simplify, leaving us just x on that left-hand side. We now have to determine what 18 divided by negative 3 is. Well, I know that 18 divided by 3 is just 6. And since it's negative 3 divided into a positive 18, and only one of those terms are negative, we know that our answer here is going to be negative. A positive divided by negative gives us a negative. A negative divided by negative gives us a positive. We just want to double check this answer here by plugging it back into the equation of negative 3 times x is equal to 18. Well, it's negative 3 times negative 6 is equal to 18. Well, I know 3 times 6 here is going to be 18, but negative 3 times negative 6, two negatives also give us a positive, also give us 18. And since I got 18 is equal to 18, I know that x does in fact equal to negative 6. We're now going to look at these two problems here for learning goal 25, where we want to simplify both these expressions. So first we want to simplify and solve. Not just simplify here, I apologize. We want to first combine our like terms, and then we do these two steps to try and solve this out. So we combine this 6x and this plus 4x to get 10x minus 10 is equal to 38, combining those two terms. We now place that line in the middle, and we want to try and do a reverse order of operations, meaning to solve the value of x, we want to deal with addition and subtraction first, and then multiplication and division, and then exponents, and then finally deal with parentheses. So first we want to try and add 10 to both sides of this question, and we get 10x is equal to 48. And now we want to try and divide both sides by 10. We divide by 10 here, divide by 10 here, and we get x is equal to 4.8. Try that one more time here with question 99. For question 99, we combine together this 4x with this negative 3x. These combine together to give us x, because 4x minus 3x just leaves us single x. We drop everything else down. Minus 14 plus x is equal to 14 here. We now want to try and deal with that minus 14, placing that line down the middle. We add 14 to both sides, canceling out that 14, and we end up getting x by itself is equal to 28. We now want to explore that angle 26 here, where for angle 26, we're going to write the word sentence as an inequality. We know that there are going to be inequalities, so we want to try and look for those phrases that tell us what the comparison is. So for example, with 101, a number w is less than negative 5, is less than is a comparison. So we know there's going to be w on one side, negative 5 on the other, with that inequality of is less than in between them. So I want to try and remember, is less than is going to be that symbol there. Perfect. Try that one more time here. The difference between x and negative 3 is at most negative 7. So we know the comparison here is at most negative 7. So on the left side of the equation, the difference between x and negative 3, well, you know difference refers to subtraction. So we want to write out x minus negative 3 and negative 6 on the other side. Well, is at most negative 6. So is at most is negative 6. Let's use that comparison again of dollars in my pocket. If I had at most $5 in my pocket, I'm saying that I could have things less than that amount, but I get right up to $5. So is at most negative 6 here would be saying that this value is less than or equal to negative 6. This here is the inequality for 103, while this here is the inequality for 101. Let's try out that next learning goal here, where we want to try and solve out these inequalities, but now we do need to do something with these symbols. Remember before we were solving inequalities with adding and subtracting? Well, if we're dividing or multiplying by a negative, we need to flip those inequalities. So to solve out these inequalities, we still treat them like an equal sign at the very beginning. We put a line in the middle, and we want to do that inverse operation affecting our variable. In this case here, negative 4x is greater than 12. We want to divide by negative 4, because it's multiplying x to both sides. This negative 4 simplifies with this negative 4, and we end up getting x by itself. 12 divided by negative 4 gives us negative 3, but notice what happened to the inequality sign. Because we divided by a negative number, we need to flip that from greater than into less than. This is only true if we're multiplying or dividing a negative number. If this was like a positive 4 here, we do not flip the inequality. So the answer for 105 here is x is less than negative 3. Try that one more time. 107. We simply place a line right down the middle for negative 3x is greater than or equal to 18. We're going to divide by that coefficient of negative 3 on both sides here. These negative 3s, they cancel out, leaving us x. And 18 divided by negative 3 gives us negative 6. And since we divided by that negative number, we're going to flip this inequality from greater than or equal to less than or equal to. And that gives us our inequality for 107. Moving on to 109 for learning goal 28. We're going to solve these inequalities here using two steps. Keeping that in mind where we divide and multiply by negative, we flip the inequality. For 109 here, you place that line down the middle. For negative 4x minus 4 is greater than 12. We first add 4 to both sides, going in that reverse order of operation, addition and subtraction first. We get that inequality of negative 4x is greater than 12 plus 4 gives us 16. Our inequality hasn't flipped yet because we added some number. Even if we add a negative number or subtract a negative number, we don't flip the inequality. We only flip it when we divide by some negative number like we did now. That negative 4 is multiplying that x. So we divide negative 4 to both sides. We get x by itself is less than 16 divided by negative 4 gives us negative 4. Try this one final line with 111. Put that line down again. We're going to add 3 to both sides here. And we end up negative 3x is greater than or equal to 21. We then divide negative 3 to both sides. And we're getting x is less than or equal to negative 7. That there gives us our finished answer for question 101, so 111 and 109. We now want to dive back into our area questions with trying to find circumferences of the circles next. For circumferences of circles, we want to try and use that equation here of c is equal to 2 times pi times r. When we want to find the circumference of this circle, we first need to identify what the radius is of these circles. We know the radius in this case here is equal to 4 inches. So to find circumference, all we do is plug in that 4 inches into 2 times pi times r. we're not able to multiply that out with our calculators. So we do 2 times pi times 4. We end up getting that circumference of 25.13 inches, making sure to keep that unit as the same as our radius. But notice for 115, what is the circumference of this circle? We're not given the radius of this circle. We still want to use that equation of c is equal to 2 times pi times r, and in this case, we're given the diameter, the full distance from edge to edge, as 12 inches. We know that the diameter is just twice the size of the radius. So to find the radius, we just take half of the diameter. And if we take half of 12, we end up getting 6 inches as our radius. Now we'll plug 6 into our equation here. For the circumference is equal to 2 times pi times 6 inches. We now plug that into our calculator here. We do 2 times pi times 6. And we end up with our circumference is equal to 37.699 inches. Now notice for the 699 inches, you are able to round up that second decimal place. That second decimal place is larger now because that third decimal place is larger than 5. So we're able to round that 9 up to go up 1 higher, which causes it to also round that 6 there. So we end up getting 37.70 as the most proper answer after rounding. And just to clarify that, we do end up getting that 37.69. And we're just rounding to that nearest decimal place. We're now able to look at the area of the circles here, where we're going to find what the area of the circle are. Well, we know the area equation is just going to be pi times our radius squared. So our first goal here is just to determine what the radius is. We know that the radius is going to be that half distance from the center, the edge of the circle. So we know our radius here is going to be 4 inches again. The area then is equal to pi times 4 inches squared. So we plug it into our calculator, where we just do 4 times 4 times pi, which gives us the area of 50.26 inches squared. There's our for that first problem. For the second problem, again, we're given the diameter of 12 inches, not radius. We still may use the equation to find the area as pi times r squared. But again, if the diameter is given for these problems, cut it in half to find the radius. So the radius here is going to equal 6 inches. When we plug 6 into this equation here, our area is going to be pi times 6 inches here, or 6 times 6 times pi, is going to give us an area of 113.097 inches squared. And since that third decimal place is above the value of 5, we're able to round that second decimal place. But since that rounds it again over this decimal place, we end up getting that final answer of 113.10. We're now able to move on to Rainbow 31. Rainbow 31, we want to try and find what these value of x's are when we're given these right or straight angles. Determine what the missing angles are. What's the value of x? We know that for these right angles here, they're equal to 90 degrees. And I know that 90 is made of those two different angles of x plus 62. I'm able to solve for x by just doing that one simplification. We just subtract 62 to both sides here, and we're able to say that x is equal to 28 degrees. The important thing for question 121 is knowing that the right angle is equal to 90 degrees. In the same way that the important thing for 123 is that this angle, this straight angle here, is equal to 180 degrees. Anything that's a flat line is 180 degrees. In this case, it's these two angles that make that 180 of y plus 77. We still want to solve it out this like simple equation. The line in the middle, minus 77 to both sides. We end up finding that y here is equal to 103 degrees. We're now able to move on to learning goal 32. We're in learning goal 32. We want to try and solve out these questions by combining like terms and solving for x. In this case here, for question 25, we have this negative 10x and this plus 5 as our only two like terms. So we're able to say that negative 10x plus 5 gives us negative 5x. And then we drop everything else. Plus 28 is equal to negative 21. We now solve for x using those multiple steps. We put that line in the middle here. We subtract 28 to both sides, and we end up getting negative 5x is equal to negative 50. We now divide both sides by that coefficient of negative 5. So divide by negative 5, divide by negative 5, and we end up getting x is equal to positive 10. Try that one more time here with question 127, where we first need to distribute that negative 4 in both of the terms. For the negative 4 there, distributes into that 2x, as well as that negative 2 here. So negative 4 times 2 gives us negative 8x. Negative 4 times negative gives us that positive 8, and then we add on the remaining part of our problem. Then we try and combine these two terms of negative 8x and positive 3x, which does combine together to get negative 5x. Now we write down the rest of the terms. Plus 8 is equal to negative 42. Put that line down there. Subtract that value of 8. Subtract that value of 8. We look very familiar. Negative 5x is equal to negative 50. And we just divide by negative 5 one final time here to end up getting that x is equal to positive 10 yet again. Let's try these problems one more time here with question 129. We're going to try and solve out on both sides of the equation. We're still looking at 132. We're still solving out these equations here. Where in question 129, we need to distribute that negative 7 to that x and that negative 2, while also combining like terms on the other side of the equation. For the other side of the equation, we'll combine terms of 6x and 5x. On the left-hand side, that negative 7 times 3 gives us negative 21x. That negative 7 times negative 2 gives us that positive 14 is equal to 6x plus 5x gives us 11x. And then that plus 54 just drops down to the other end. We now want to move all of our constants to one side of the equation while moving all our variables to the other side of the equation. I mean this is, I want to move this negative 22x over on this other side and move this 54 onto this side. To do that, I place my line down the middle, and I can add 21x to this side and add 21x to this side. They cancel out over here, and then being 14 is equal to 11x plus 21 here to be 32x plus 54. I'm now able to subtract 54 on this side, subtract 54 from this side here, and I end up getting this left-hand side is 30, and on this right-hand side, I get 32x. Now that final step here is just to divide both sides by 32. We divide this side by 32, divide this side by 32, and we cancel out those 32, so we get x is equal to 30 divided by 32 is a decimal of 0.9375. Math, and we're good. Now we're going to look here at a multiple step problem. We're going to solve out these two problems here, practicing transferring variables across the equal sign. But here, I don't really like dealing with these negative values here, so we're going to try and solve out the equations. I want to try and move all these negative terms of a variable to the positive side, and all these constants over the other side. So here, my line down the middle, I'm going to add 10x to both sides, and I want to make sure I'm combining it to the left terms. So these two 10x's cancel out, give me 14 is equal to 15x plus 44. Now I want to subtract 44 to both sides, and I end up getting negative 30 is equal to 15x. That constant is divided by that coefficient of 15 into that x, and we end up getting x is equal to negative 2. So that one more time here with 23, where we're double distributing. We're going to take this 3 and multiply that x, take this 3 and multiply that 4. 3 times x just gives us 3x. 3 times 4, though, gives us 12. We want to try that one more time with negative 5 times x, and then negative 5 times negative 4, which equals negative 5x plus 20. We now move all of these terms here to one side, all these terms here to one side. All those terms of variable, add at 5x, add at 5x, and getting 8x plus 12 is equal to 20. I'm going to subtract 12 both sides, and I'm getting this 8x is equal to 32. And the final step is divided by the coefficient in front of us, where we divide by 8, divide by 8. We get x is equal to 4. Combining these terms across the equal sign, I take the inverse operation of that term. We're now going to look at learning goal 34. For learning 34, we want to solve for the variable of y. But notice, for both of these problems here, we have two variables, y and x. In these cases, we move everything, including that variable of x, to the other side of the equation, and leave y isolated. Do this for question 5. We want to add and subtract first, so we want to subtract that term of x on both sides. When we subtract x on both sides, notice that 6 and x are not like terms, so they do not combine together. So what we're just left with is 2y is equal to 6 minus x. We now are trying to divide out that 2 coefficient of y, where we divide by 2 to both sides. And since we're dividing by 2 on this whole side here, we can make a large fraction, where we get y is equal to 6 minus x, all divided by 2. And there's our finished equation for that 135. For 137, we want to do something kind of similar. We keep that line down the middle, subtract that 12x to both sides, where we end up getting y over 2 is equal to negative 22x plus 3. We now want to multiply 2 on both sides. And since I'm multiplying by 2 to this whole right-hand side here, we're actually distributing that 2 into both of the terms. That finished answer is y is equal to negative 44x plus 6, where 2 times negative 22 gives us negative 44. 2 times 3 gives us 6. We're now able to move on to that learning goal there. We want to determine the missing angles across the parallel lines and transversal. What I want you guys to do immediately when you see here is I want you guys to group these angles into pairs. We know that this 140 degree here is exactly equal to its vertical pair of angle 4. So we know right off the bat that because these two angles are vertically paired with each other, we know that angle 4 is equal to 140 degrees. We also know that angle 5 and angle 140 degrees are corresponding angles. Notice how these two angles here, they're shaped almost identical to angle 5. These angles here, these are two parallel lines being crossed by one transversal line. We know that these two corresponding angles are also equal to each other right off the bat. So we're able to say that angle 5 is also equal to 140 degrees. And now that we know that angle 5 is 140 and angle 4 is 140, we know that angle 8 is 140 here because angle 8 and angle 4 are corresponding angles, and angle 4 is 140, we know equals 140 here, and angle 5 and angle 8, those are vertical pairs. Angle 5 is 140, so we know that angle 8 also needs to be equal to 140 degrees. This here is the first group that I want you guys to identify. This here with this here, and make these all squares here. All 4 of these angles here all equal each other. They're all the exact same angle. What we want to find now are all these other angles, 2, 3, 6, and 7. But notice we have a supplementary pair between these angles. We form a straight line here. So we know that these two angles need to add up to 180 degrees. Since I know that angle 2 plus 140 make up that straight line angle of 180, I'm able to solve for angle 2 by subtracting 140 to both sides, and I can see that angle 2 is equal to 40 degrees. If I know that angle 2 here is equal to 40 degrees, I also know the vertical pair is also equal to 40 degrees. We're able to say that angle 2 is equal to 40, and angle 3 is equal to 40. And notice their corresponding pairs of 2 and 6 are also equal to 40. 6 and 7 are vertical pairs, but 3 and 7 are also corresponding pairs. We know that 7 is equal to 4. And here tells us all the angles for this problem now. We find these supplementary pairs are together to get an 80. These vertical pairs are the same. These corresponding pairs are the same. And these internal alternate angles are the same. These external alternate angles are the same. We're going to move on to that learning 36. We're learning goal 36. We want to determine what the missing angle is of these triangles. Like straight line angles, triangles sum up to 180. So for 3 of these angles here, where one of them is x, but 2 of them are values, we solve for that third angle by making the equation of 180 is equal to x plus the value of 70 plus 60. Now let's solve for x here. First, we combine like terms of 70 to 60, gives us 130 degrees, plus x is equal to 180. We now subtract 130 to both sides, and we find that x here is equal to 50 degrees. Let's try that one more time here with example 148. 148, we know that we're dealing with triangles, so I'm going to set this equation equal to 180. And now we can sum or add all these things together. We get x plus 109 plus 32. We first combine like terms, so 109 plus 32, which gives us x plus 141 degrees is equal to 180. We now want to subtract 141 to both sides, and we end up getting that x here is equal to 39 degrees exactly. Now we move on to that next learning goal here. For that learning goal 38, we want to solve for y when x is equal to 3 and z is equal to 5. So we're trying to find a variable when we're given the value for these variables. In this case here, y is equal to 4x minus 2. So first let's plug in the value of x in that equation, where y is equal to 4 times 3 minus 2. We know 4 times 3 is just going to give us 12. So we know y is equal to 12 minus 2. And 12 minus 2 gives us 10. So we know y for the problem here is equal to 10. Let's try that one more time with 152, where x and z are being plugged in. We know x here is 3. We know z here is 5. We have that new equation y plus 3 is equal to 2 times 3 plus 3 times 5. We just multiply this out to get y plus 3 equal to 2 times 3, which is 6, plus 3 times 5, which is 15. When we add these together, y plus 3 is equal to 21. We now solve for y by subtracting 3 both sides, and we end up y is equal to 19. We want to try and plug in those values of the variables we found and solve out for that missing variable y. We're going to move on to that running goal for D9. We want to find slope from these given 2 points. For both of these problems here, we use that simple equation where we're taking our second y value and we're subtracting it by our first y value, and then divide those two y values by the second x value minus the first x value. And now these x's and y's need to determine which place the first point and the second point. Well, the first point came first. So we know that negative 4 is equal to our x1, and that 2 is equal to our y1. We know 3 here is equal to our x2, this is our second point. And we know this 3 here is equal to our y2, this is our second value. Now let's plug in these 4 values here in this equation. y2 is equal to 3 minus y1, which is equal to 2, all divided by x2, which is equal to 3, minus x1, which is equal to negative 4. Keep in mind, we're subtracting this negative 4 in a second. So 3 minus 2 here gives us 1. 3 minus a negative 4 is the exact same as adding a positive 4, which gives us 7. So we know the slope for this problem here is equal to 1 over 7. Let's try this one more time with 1 6. We're still going to use that same equation of y2 minus y1 all over x2 minus x1. We're going to make this the first point here, so x1, y1, x2, and y2. We now just plug these values into the equation, where y2 is equal to negative 6 minus our y1, which is equal to 4. We now plug in this x2, which is equal to 1, minus our x1, which is equal to negative 5. So negative 6 minus 4, more negative, ends up being negative 10. 1 minus negative 5, well, that's a double negative, so it's actually positive. So 1 plus 5 gives us 6. Now notice for this slope here, we can simplify this fraction like earlier in this. We want to determine the greatest common factors, both 10 and 6. They both have to be even, so we divide 2 in both of them. So this negative 10 over 6 divided by 2 over 2 gives us a value of negative 5 over 3, which is the simplest form for the slope for 156. We're going to move on to that running goal 3. We're going to go 3 here, and graph these two equations, and all we need to do is identify two specific values. 1, what's the y-intercept, and 2, what's the slope of the problem. The y-intercept here for 158 here is this constant value all by itself. So the y-intercept, or b value, is equal to negative 2. We know the point for the y-intercept is going to be 0, comma, negative 2. That's the very first point we want to plot on our graph here. We do that like this, and put the very first point, we're at negative 2, and now we're going to find the slope. We're going to be the coefficient in front of that y there. So the coefficient in front of that y is 1 over 2. So we know the slope is equal to 1 over 2. We know that slope is just rise over run. We know we're going to be rising up 1 unit while we run to the right 2 units. Now when I say rise and run, what I mean to say is from this point here, we want to go up 1 unit, and then we want to go to the right 2 units, 1, 2. With that little staircase, we want to place a point at that new point. We want to go on again over 2 at that point. So we go up 1 over 2, the next one, kind of ran out of space. So we go back in the opposite direction. We go down 1 over 2, down 1 over 2. Down 1 over 2, and we'll reset the board. Now we're going to all these lines, little arrows at the end of the lines. Let's try this about 3 more times. We have this 160 here, we have this 162 here. Let's try 3 more times actually. We want to identify what that b value is. So we know b here is equal to 2. So that first point we want to place a point on is at that 0, comma 2. So we go to 2 now on our y-axis point. We know that our slope here is going to be that coefficient of x. So we know m is equal to negative 1 over 2. Since it's negative 1 over 2, our rise is actually going to be down 1, and our run is still going to be us going to the right 2 units. So from this first point here, we go down 1 over 2, we place that first point. We go down 1 over 2, we place that next point. This is going the opposite direction, we're going to do the opposite what tells us. So we go up 1 to the left 2, to the next one, up 1 to the left 2, to the next one. Now we're able to connect all of our lines together using that straight line. Try this one more time here with question 162. We first identify what that b value is. That b value in this case here is equal to negative 4. Taking the point 0, comma, negative 4 as our very first point for our y-intercept. So we go down to negative 4 on our y-axis, placing that first point. Now we identify the slope of this equation. We need that coefficient directly in front of that x. But notice for the coefficient, our m value is just equal to the whole number of 2. So to create a rise over 1 fraction, what we need to create is that 2 over some number. If we take 2 and place it over 1, we're able to do that because that is the number 1 to change any of the values. So we know 2 over 1 is our rise over our run now. We want to go up 2 and over 1. So from the first point, we go up 1, 2 over 1, place that point, up 2 over 1, place that point, up 2 over 1, up 2 over 1. I ran out of room now, and with all of these points here, I'm going to create that straight line through all of the things to finish up this problem here. Now, in these final problems here, what we're going to go from is, we went from this equation to this graph. Now, we want to go from this graph to the equation. And to do this, it's very simple. We just need to find those two pieces of information. That first piece of information is what y-intercept. Well, the y-intercept here is just when that line crosses the y-axis. In this first problem, 164, we know it precisely crosses at that point. So now, we need to just identify what that point is. That point here is just 0, comma, negative 3. Since it's 0, comma, negative 3, we know the y-intercept is going to be negative 3. We now try to locate on this line here that next point is. In this case here, we're given to us. So we know that from this first point to the second point, we need to go down 1 unit, or negative 1, and then over 1 unit, or positive, to the way positive. So we go down negative 1, and then we go over positive 1. And we say that the slope here is negative 1 or positive 1, which simplifies to just negative 1. We now write out that equation. We're still going to use that base equation of y equals mx plus b, where m is going to be the slope, so we write y equals negative 1x, and b is going to be our y-intercept. It's plus negative 3, we just write as minus 3. We're going to 2 times with 156, 166, and 168 to close off. For this question here, we want to identify what that y-intercept is. In this case, given to us directly as 0, comma, negative 5. So we know that that y-intercept is going to be negative 5. We now want to try and find what the next point is. The next point is going to be 2 as well, as 3, comma, 1. We want to try and find that rise over 1 for the problem here. So we go up 1, 2, 3, 4 to match the elevation at that point. So we add 4, go up. So we know for our slope, it's going to be 4 over the amount we do for runs. We start the elevation, go 1, 2, 3 to the right. We're adding 3 to the right here. So we know that our run was 3. If we know 4 over 3 is in its simplest form, we're now able to write out that here as that y equals mx plus b. We know m equal to 4 over 3. So y is equal to 4 over 3x plus our b value. Our b value is that negative 5 again. So it's going to be y equals 4 over 3x minus 5. That is our equation for that graph there. And for the final question on our study guide, question 168, we're given this graph here without any coordinate given, and we're asked to find what the equation is. We first find what that y-intercept is, where we find that y-intercept is right here, but since the graph goes by 2s, we know that first point isn't 0, comma 1. If we look up on the graph here, running by 2s, that first point is actually 0, comma 2. So our y-intercept, or b value, is equal to 2. Also, to keep in mind when we're rising in line that each of the values here are 2 units. So see this point here and this point here. This point here is the right between these two values here. I want to grab that. We're going to use that value here. This is in between the value of 2 and 4. So I'm going to grab that between 2. I go right where these lines are crossing. From this point up to that point, I go 2, 4, 6, 8. And I'm counting by 2 because each line is 2 units. And now I go over 2, 4, 6. I go over 6 of these values are also by 2 units. So our rise over y is going to be 8 over 6. In this case, since they're both even, we can divide by 2 to get that simplified slope of 4 over 3. Now that we know that our slope is 4 over 3, and we know that our y-intercept is equal to 4 over 3, right, that way of y equals ms plus b, where m now replaces our slope of 4 over 3 x plus our y-intercept, which is equal to 2. Thank you guys very much for tuning in for our study guide live stream for our semester 2. If you have any questions at all regarding any of the problems we happen to go over,